Um, if you take SOA, there are majorly three elements are there, three characteristics in SOA, core elements: service, ESB, and loosely coupling. We have to understand what is a service, what is the significance of ESB, enterprise service bus, why we need ESB, and what is the need of loosely coupling. Loose coupling is very important. Nowadays, it plays a very important role even in the programming languages. In case of asynchronous call implementation, if you want to call something uh, asynchronously, then we have to understand loosely coupling characteristic. What are the principles, what are the fundamentals about the loosely coupling. These three are very important to understand SOA, how it can be independent of the technology, independent of the um, platform, independent of the network. These three plays very critical role to get the independence. So as we already discussed, SOA, service, let us go through one by one of those three. What is service? Service is nothing but a functionality or work to be done. That's what it is, like a simple function in object-oriented programming. Yeah. Service is generally service should be as small as possible for reusability purpose. Just to read the data, to write the data, to update the data, something like that. As mentioned here, could be as getting some information from the user or fetching the data from the database. Even that is a low level service. Services can be composed, right? Composed services are nothing but a higher level services used to work on top of these small services. Small services, another name of the small service is microservices, right? Micro, nowadays lot of importance, everyone industry is trying to implement the microservices, and these microservices can be distributed because these are the independent of the operating system, independent of the technology as well as the network. Most of the things are independent, so you can distribute, you can deploy anywhere in the world, anywhere in geographically. So you can integrate all these things. You can develop some kind of composite services on top of that, and we can use it, right? So microservices is very important from reusability point of view. That's what it says. Micro means very small functionality, so should be as small as possible. That's what. And on top of these microservices, we can implement composite services. Otherwise, we can call it as a macro services, higher functionality services. Even though these higher functionality services can work on top of these microservices. And another one is that's what the service is, nothing but a functionality, and your functionality should be as small as possible for reusability. Even reusability improves the productivity, right? So ultimately we need the productivity to deliver your product as quick as possible, or to deliver your solution as quickly as possible with better quality. Efforts can be reduced dramatically if high degree of reusability in your project, right? So reusability should be maximum for better quality, to reduce the cost of the product. Reusability plays very significant role that you can achieve by using the microservices. That's what the point here. Now, another element is enterprise service bus. So it is mainly to interoperability between these services, microservices, or whatever service. It can be a composite service, higher level macroservice also, but mainly for communication between these services. Interoperability between these services can be achieved to the maximum by using the enterprise service bus. It makes very easy. Even it enterprise service bus address the common concerns. Whatever issues are there, common issues are there, while establishing the communication between these services can be addressed optimally, addressed by this enterprise service bus. So this is also very much useful, not only for communication, even from productivity point of view. All integration, common concerns, common problems can be addressed by these enterprise service bus. We will see what are the advantages, what are the characteristics, and all those things. Even these services, by using these enterprise service bus, the services that are implemented in different technologies, different languages, can communicate. That is another advantage of this. Communication makes very robust and very productive by using these enterprise service bus. Of course, last principle is these services, service-oriented architecture should be loosely coupled. I think you might have heard about the counterpart of the loosely coupling is tightly coupling. Tightly coupling and loosely coupling. Tightly coupling is nothing but a very hugely dependent each other. Dependency is very high in case of the tightly coupling. If one interface is changed, another interface also should be changed. That's what the tightly coupling. Loosely coupling is nothing but the dependency between these interfaces are very low. Opposite of the tightly coupling is nothing but a loosely coupling. So we don't want to tightly coupling in the service oriented architecture. We have to consider the loosely coupling, independence of these services. If one service fails, another service should not be failed because of the first service failure. Fault tolerance should be there. Because of one service failure, other service, whole system should not be down, right? That's what the fault tolerance. This fault tolerance and asynchronous communication can be achieved by using these loosely coupling. At the time of designing your services, it should be loosely coupled. By if it is loosely coupled, you can get the asynchronous kind of communication, as well as fault tolerance. You can improve at higher levels. That's what, even if one thing is changed, these services can be evolved independently of other services. So that's what you can achieve it. That's why these three are very important characteristics. We have to understand deeply about these three concepts. So let us look into the one by one. What is a service? Service used to have some kind of functionality, as we already discussed it. Majorly the services relates with some kind of policies. Policies are nothing but rules and regulations. It has some kind of a purpose. Any kind of service has some kind of purpose. Yeah, and those services can be implemented by to automate your business process. These services should be automated by your applications or by your IT infrastructure, right? That's what you want to ultimately achieve it. So here it has to be done with the different teams, of course. These services will be implemented by whole policies or business process will be implemented by different team members, different teams in your organization. Suppose if you take any kind of an organizations, there may be different kinds of departments used to be there. All these departments collectively automate their business process or their business process, right? So they need to work together. Each department used to have their own policies, own rules. Um, Suppose if you take software engineer, maybe software engineer, senior software engineer, and then principal engineer. These are the hierarchy in the development. If you take software quality assurance, maybe tester, senior tester, and maybe principal tester, and maybe next level is architect or something like that. Even if you take HR or sales, these are used to have different kinds of roles. Each role has a specific functionality. Suppose if you look into the service is nothing but some kind of functionality as per the YS's definition. Performance of the work by one for another. Performance of the work or a function by one for another. So another is nothing but a caller, and callee is going to perform whatever functionality is requested by the caller, right? So actually it is a function. It's like a function, independent function. We can call it independent function. We can call it as a service, but somewhat meaningful in your business process. That's what it signifies. The business person should be able to understand the functionality provided by the service, right? So the somewhat higher abstraction should be there in your for your service. We generally function user to take some kind of inputs and process it and process and then produce the output. Even service also same thing. It has to take some kind of inputs and then process it and return some kind of information or output, whatever you call. The next level of the data is information, right? It can give some kind of more meaningful data. That's what it says. Output should be more meaningful. Then we are calling it as an output is an information, right? Mm, yeah. SOA is a software architecture that starts with interface definition and builds the entire application as an interface. Entire application is nothing but a higher level services. Higher level services used to address, used to handle all your business process or most of your business process, right? Or part of your business process. It all depends upon what level of abstraction that you are maintaining. That's what the main thing. So the client can call these higher level higher level services. Higher level services in turn call the lower level services. There are a lot of levels of services are there. Process service, composite service, and low level services. That's what the meaning. So as it is there in the object oriented programming, there are basic objects and higher level composed object. Different levels of composed objects used to be there. So that's what here also. But object oriented is very language dependent, and lot of dependencies are there. But the service is similar to function only, but lot of independence, technology, platform, and all those things. Suppose if you look into service characteristics, there are a couple of characteristics are there as per SOA specification. One is a self-contained. Every service should be self-contained. It should be governed, independent, autonomous, right? And it should have some kind of an abstraction. Abstraction is nothing but a implementation. How the client can call these service. What is the name of the service and what system you can invoke this service? What are different types of parameters and what is the order of the parameters that is supported by this service? What is the return type and on what protocol this particular service works? And all this information is a part of the service. That's what we are calling it as a WSDL. WSDL is nothing but an abstraction of the service that you can access over the network. Visibility of the service is nothing but a that service should be visible. That is through the some kind of directory services are there. That UDDI is a good example of the example where you can get description about the service or what are the services that are available in the environment, right? Yeah. Another one is stateless in nature. Most of the services should be stateless in nature. Every request should be treated as a fresh one. It should not depend, it should not carry the previous request data in the current request. Maybe for better performance. Suppose some requests need the previous request data in the current request. Of course, that you can handle it programmatically, but not by default. These stateless, all the services should be stateless because stateless provides a better performance. Better performance. Idempotent is nothing but a consistency. If you invoke the particular service and number of the for same kind of inputs, if you invoke that service, you should get the same kind of output. The result should be more consistent. You should get the same output for the same kind of inputs, right? That's what. And another one is reusable. These services should be more reusable, and it should be composable. Small services. Some services you can develop on top of the small services, small functionality services, and each service you can put some kind of conditions, some kind of requirements, some kind of constraints. Such kind of constraints we can call it as a service level agreements. Maybe you can specify, okay, this service should produce the response 0.2 milliseconds. If response is taking more than that 0.2 seconds, maybe you can get some kind of alert or some kind of event, some kind of notification you can generate. These are very useful to provide some kind of reliability, some kind of time constraint, some kind of real-time applications. For the real-time application, these SLAs, not only real-time and even to measure the performance, to make some kind of agreements, some kind of agreements between the provider of the service and the consumer of the service. Whatever is the conditions, terms that you can put it in the SLA. So it can be monitored. If there is any violation, immediately it can generate some kind of an alerts, something like that. SLAs are very, very important nowadays because most of your critical business critical things are running by using these services. So these services should fulfill whatever they promise. They have to deliver it. If they couldn't deliver, then there should be some kind of measures, some kind of action should be taken. Committing so much and not delivering is not good, right? So that's why there should be some kind of monitoring mechanism. That monitoring mechanism you can achieve it by these SLA, service level agreements. For each service, there should be some kind of precondition and post condition before requesting and after requesting. What are the conditions are required? What kind of things should be satisfied? How it should be before invoking, after invoking, something like that. Interoperability, these services should be communicable with independent of the technology, whatever we are calling it. Most of these services are implemented as a web services, as we already discussed, as we are going to see in the coming chapters. These services can be implemented in two ways. One is the SOAP based web services, another one is RESTful web services. These are the two APIs that are available to implement these SOA recommendations. Service can be implemented either by SOAP-based web services, another one is RESTful web services. And these SOAP or RESTful web services are almost 85 to 80 to 85 percentage compliance of SOA guidelines or specification. This was a brief introduction about the SOA. These are the characteristics about the SOA. Let us go through the next one, loosely coupling. Loosely coupling is nothing but a these two systems, two services should not be dependent, tightly dependent between these two, between the services. All the services, these services should be evolved. There is no dependency. Ultimately, it leads the fault tolerance. If it is loosely coupled, you will get a high degree of fault tolerance. One service failure is not going to affect another system. Good example is flight booking system should not go down because of some problem in one service. Other whole system should not be bring down. So these even if it is loosely coupled, you will get a high degree of robustness of uh, your system. That's what fault tolerance you can achieve it. This what actually for here. Let us assuming that system one or service A, service B. What happens in the loosely coupled system is this sender and receiver, sending sender and recipient are not going to contact directly. There is no direct contact. If system A want to communicate with the system B, it is going to contact the middleman. So here the middleman is nothing but your ESB. It is going to put the data in the ESB or the queue. Queue can act as some kind of a middleman, middleware. And whenever the system B is up and running, then it can check into the middleware or the queue or ESB. Then if there is any message for that service, it can read that request, the data, and then process the requested service, and then put back the response in the middleware. Middleware can be either queue, or it can be a ESB, enterprise service bus, or it's some kind of a middleware software. And whenever this system A is up and running, then it will check the middleware, is there any response for my previous request. So it will, if there is a response, it can take the response from the queue, and then it can process it. So point here is that in the loosely coupled, there is no direct communication between the sender and recipient. There is a middleware. That middleware acts as a store and forward kind of mechanism, and it has persistence in nature. Middleware should be persistent in nature. So that's what it represents. That's a mechanism. That kind of mechanism you should establish in your software, in your design or architecture, while for loosely coupling in nature. So any service should not communicate directly. It should communicate through the middleware. Middleware can be a queue, a persistent queue, or it can be an ESB, or any other middleware, or JMS, Java Messaging System, can act as a middleware. So it can put it there. And basic functionality of this middleware is store and forward. It will take that request, it will take it, and then it will store, and whenever the recipient want it, it can forward, it can produce the response, send back the response to the recipient, send the response to the recipient, and recipient take that one and process it and put back the response in the middleware. And whenever the receiving party is up and running, then we can get that, we can take that response, and then we can process it. That's what the major thing. It is the this mechanism is very useful, even to implement the asynchronous communication. Asynchronous communication is nothing but a when the sender is sending data, receiver need not be up and running. Recipient or receiver need not up and running, right? So because the sender is not going to interact directly with the recipient, it is communicating with the middleware. So middleware takes the request, and whenever recipient is up and running, it will directly contact the middleware. Is there any response, any request for me from any other client, any other system, any other service? Then it will take that one. If there is a request, there is a message for the particular service, then it can. So that's what the asynchronous. Whenever the recipient, the receiver process the data, and while putting back the response, even that previous sender need not be up and running, right? Even it can put the data response in the middleware, and whenever that previous requester is up and running, it can look into the middleware, and it can check the middleware, and then it can process it, right? That's how fault tolerance, high degree of fault tolerance, as well as very easy to implement synchronous kind of calls by using these loosely coupling design mechanism. So loosely coupling, nowadays, a lot of loosely coupling, most of the programming languages are providing these loosely coupling APIs or asynchronous APIs. Internally, there is no direct communication between the sender and receiver. You are going to put in the asynchronous call, you are putting the data in the queues, and the queue used to store that request, and then forward that request whenever the recipient is up and running. That's how you can get this asynchronous implementation. That's what the brief introduction about the loosely coupling. By using the loosely coupling, three characteristics are there. One is you can get high degree of fault tolerance. You can get asynchronous kind of calls. You can implement asynchronous kind of calls. Another one is dependency. Evolution of these things are very easy, in loosely coupling. Another one is next one is about the ESB, enterprise service bus. You know, enterprise service bus plays very significant role. It is a middleman for interoperability between the services. It is mainly communication channel, communication channel, and this communication channel plays very significant role even for, to make these services loosely coupled. And if you look into this, ESB is nothing but your system bus in your computer, right? In your PC or in your laptop, there is a PCI kind of bus inside to connect all IO devices. Of course, here ESB is a dedicated bus that is used to connect to different services, small services or bigger services, and it can be implemented over your TCP/IP. This is what your TCP/IP through. That is what the media through which you can these kind of messages used to be routed, right? And then these are the some of the major functionalities or responsibilities that you can get it from the one is the connectivity, very dedicated bus, so you can get better connectivity between these services. And data transfer, different types of data types are supported, and because it can act as an adapter. If these services are not compatible, there is some kind of configuration where you can get these data type mismatch can be addressed. Even the routing, dedicated routing, load balancing, lighting, fault tolerance routing, all these things are achievable. Even reliability, reliability of your packet, reliability of your request, you can get. Even the as the number of these services grow, management is also one of the major challenge that you can achieve it through these bus and monitoring and logging. You can check it out what kind of messages that are being exchanged, what kind of manipulation that you want it. All these things you can achieve it. Lot of advantages are there. If any service can connect and any service can detach without affecting the existing system, existing services. That's another advantage is there. A lot of things are there. You can check it out. ESB plays very significant role, and that's what the brief introduction about those three elements: service, loosely coupling. Another one is ESB. Now, if we look into the different types of services, as we already discussed. Different service, three types of services are there. Those are the basic services, very low level services. Another one is composite services. Those are the composite services, nothing but a composition of these basic services. And these process service is nothing but a service that is close to your business process. So these are nothing but a basic data read, write operations, very basic level. Basic service is nothing but a, so here if you look into that, reading the data, writing the data, something like that, these services can be invoked by this frontline services, frontline APIs. Frontline APIs, this is a frontline UI. This UI invokes these services and then get the functionality. So it works. These are the basic level. So you can read it. What is the composite is nothing but a, on top of these basic services, it is a composed objects are there, similar to composed objects. On top of these basic services, you can develop some kind of composite service. Otherwise, we can say that orchestration. Orchestration is nothing but a using these small services, you can get a bigger functional. You can develop a bigger functionality services. So orchestration is one of the major functionality that you can get it in the composite level. Arranging these small services, designing these small services to get a bigger functionality to address your business process. That's what here there may be shopping cart or maybe a payment system or some kind of browsing catalog and all are the good examples of this um, uh, good examples of the composite services. Another one is the business service. Business service is nothing but a that is very close to your business process, that are used to automate your business process. If you look into this, this is what the business process, very big process will be there. The business process will be divided into sub-process, and this sub-process further decomposed into small composed services. And all these composed each sub-process will be divided into different activities. In each activity used to have some kind of operation steps, and these steps and all these steps and then these activities can be at the lower level, and these sub-process can be at the composed level, and these higher level sub-process and your business higher level sub-process can be at your business process, right? BPM, business process management, that is used to define your business process of your organization. It is very high level. It is very close to your business domain. There are some kind of languages are there. BPEL, business process expression language, that is used to define uh, your business process with the help of your existing IT infrastructure. So you can decompose your business process to automate your business process using the IT infrastructure, maybe your basic services and then composite services. These are the small services. Suppose let us consider customer order is your business composite service, maybe sub process, and composite service that can be implemented by these small basic services, reading the CRM, basic data service of the CRM, basic data service of logistics, and basic service of the your billing. So you can develop higher level customer order sub process, something like that. So these are the different sub process. That's how any business process used to be automated in the service oriented architecture by using different kinds of services. Bottommost services are basic services, middle services are some kind of composite services, higher level services are the business process services which are close to your business process, higher level services. That's what the point. So this is what it higher level services are very close to your business process. Lower level services are very close to your IT infrastructure, of course, particularly your application infrastructure. So another one is these are the different kinds of services, three kinds of services. One is the basic service, composite service, and business services. Ultimately, these the three levels of services can be used to automate your business process. Uh, so that's what the brief introduction about the different types of services. And next one is about the architectural models. What are different architectural models that are available, that are there in your service oriented architecture? Three kinds of architectural models are there. One is the business or logical based. This is very close to your business. And another one is mixed. Mixed is intermittent architecture flow, intermittent of your business as well as your technical. And technical is very close to your IT infrastructure architecture. Let us go through these business or logical based. Business is nothing but here there is no ESB. There is no significance of ESB is almost nil in case here. These are different purpose, B2B application and call center and portal. These are the very functional oriented portals, right? All these portals, there is a workflow here. We are going to define this workflow. Using this workflow, these applications can work together. You can get this functionality. There is no ESB here. So it is very customized. There is no much flexibility, but ultimately you can automate your business process. Of course, level of services, backend services. Backend is nothing but your database and information, basic service, composite service. So suppose if only basic services are there, there is no much focus on the composed as well as a process level services, right? So these workflows directly invokes these basic services, and it can fulfill. It is more business oriented and it is not flexible, and agility is not highly supported in this model. So that's what the another